Hi, in this video I'm going to provide a quick demonstration on how we can actually deploy an Aruba collapsed core data center using CX switches with Aruba NetEdit. Now when we are talking about collapsed core data centers, it's important to note that while most vendors, including us here at Aruba, are talking to our customers and putting in our reference designs spine and leaf style architectures, it's still important to understand that not all customers will necessarily require a spine and leaf architecture, so we need to understand the customer's requirements. Most customers are really worried about the network uptime for these applications in this data center. They want to ensure that these applications are available and online. They want to be able to understand where or when there's any sort of potential network issues and how they can quickly fix those types of issues. And of course, automation is a key for customers moving forward too. And collapsed cores actually can really help these types of customers if the scale meets the demands of the customer requirement. So collapsed cores are environments where we're actually combining the features that typically are seen at the access or the host layer, and we're combining them with features that are typically required at the aggregation or at the core layer. From a customer perspective, they're very simple solutions to deploy because each of the devices and the servers in the environment connect directly to the pair of collapsed cores. These are usually built using end-of-row or middle-of-row style designs, but these collapsed core designs using the Aruba CX switches still provide that high availability that these customers need to ensure these applications have uptime with VSX, and we support even the live upgrades with VSX. Of course, with the CX systems, we also support the built-in troubleshooting features like Network Analytics Engine, and of course, NetEdit. And of course, within this type of environment, it really makes it simple for this east-west connectivity, which is automatically by nature layer 2. So when we're going to actually deploy this configuration, we're going to leverage NetEdit. And when we do leverage NetEdit, there's a number of ways we could actually deploy these types of plans. So we could deploy a single plan and just configure this collapsed core all with one plan. Typically, those types of plans could get quite large, and I would recommend that we actually split these plans up into a few separate plans, and then we validate each plan when we're done. And if we're okay with the way the plan was deployed, we would commit it and then move on to the next one. So I would recommend building out first a core plan using configuring VSX. So this is where we're going to configure the VSX configuration on these collapsed core switches. And then I would recommend configuring a border configuration. So this is the configuration that these switches will use to connect outside of this zone or of this pod or these devices that are connected into it. And then of course we'll finish up by configuring a host plan. So this will be the plan that will be configuring the VLANs and the VLAN interfaces that will be pointed towards the hosts and servers on the network. So let's go ahead and jump into the environment and take a look at what that looks like. So here we have NetEdit. I'm going to go ahead and select the collapsed core switches, and we'll start configuring them with a VSX plan. So this is the basic configuration that both of these switches have been applied when we racked them and powered them on, and we used the mobile app to provide this configuration. But now let's get the VSX configuration added into here. So I'm going to add the interface 1147, which is what we're going to actually use as our direct keep alive interface. Now I'm going to modify this so that the peer is actually using a different IP address here, right? So that's the beauty of NetEdit. I can do multiple IP addresses in the single configuration. Okay, so now I'm doing the ISL link. And then we'll finish it up with the VSX configuration. telling VSX which link I'm using as that actual ISL link. So I'm just going to use a 1148. Each switch in these configurations needs to be either primary or secondary. So I will provide the core 1 will be the primary and the second switch will be the secondary. And then of course configure the keep alive configuration here. So the peer here, and then the source. And of course we'll modify this for the other switch. Okay, so that's the VSX configuration. Let's go ahead and click validate and make sure that everything looks good. So everything looks good. So I'm going to go ahead and actually deploy this plan. Now I'm going to check the change validation screens here, and before we started I actually added a show VSX status command. So if I go into core 2 I can look at the show VSX status and I can see that VSX is in sync and operational. The peer is reachable. And so everything looks good. And of course we'll have the same output if we were to look at the core 1. In sync, operational, the peer is reachable. So this looks good for the first plan. I'm going to go ahead and commit this to the running config. So now I'm going to start the next plan. So I'm going to select the core switches, and this is going to be the border plan. So this is the plan that we will use to configure the border style connections outside of this collapsed pod environment. So as a fabric plan, what we're doing here is we're actually configuring the routed interfaces that are going to be facing our DC core. So let's get the interfaces configured here. We're using interface 1149 and 1150. Kind of enable jumbo frames by default here in the data center, but that may vary depending on the environment. Okay, now 1149 is going to be a different IP address on the other switch. So core 2 will use 113. Now I'm just going to copy this, and I'm going to start the new interface here. I'll paste that configuration in and just modify it as needed. Okay, so those are the physical interfaces. Now we need to get the routing protocol configured. We're going to be using BGP in this environment. Now I'm going to modify the router ID here. Now at this point, each core switch is actually going to have two separate neighbors because they're each connected to different DC cores. So in this configuration, because they have different configurations on each Core 1 and Core 2, I'm going to actually deselect Core 2 now. So now I'm actually just configuring Core 1, and I'm going to do the neighbor relationships that I expect Core 1 to see. The remote AS is 65001 for one of those DC cores. And then it's 65002 for the other DC core. Okay. And then I will enable these neighbors within the address family context. There we go. And now I'm going to add Core 2 back in there, but I'm going to deselect Core 1. So let's get the Core 2 neighbor relationships configured as they should be expected. Whoops, typed that wrong. Let's correct that. Perfect. Okay, let's select both of these again. And we can see the differences now. The configurations that only exist on a single switch are highlighted in blue here, so we can actually see which one. The first two neighbor relationships are Core 1, and the next two neighbor relationships are Core 2. Let's go ahead and click Validate and make sure this configuration looks okay. So the configuration looks okay, so let's go ahead and push it out now. Okay, let's take a look at the change validation configuration here. So I'm looking at Core 2, and let's look at this Show Interface Brief. So we can see the changes that occurred on the interfaces. So ports 49 and 50 were down, but now of course they're up. Let's see, what else do we have here? We'll look at the BGP configuration. So BGP wasn't configured before, but it's configured now. Let's look at our show IP for BGP unicast summary. So this is a great command for neighbor relationships. Let's go ahead and click refresh real quick here. See if we can get a better updated after configuration view here. And we can see now that I've refreshed it, both of these neighbor relationships are in an established state. So Core 2 has the two neighbor relationships in an established state that it would expect to see. If I go down to Core 1, I can look at the relationships here, and Core 1 also has the two neighbor relationships that are up. In fact, we could go ahead and look at these ping commands that I configured earlier. So the ping commands 111.1.1.1 is actually a host that exists directly connected to the Core 1 VSX switch, so that's good. And then 113.1.1.1, same thing except for that's Core 2. So everything looks good here. Our fabric is up and running. We are connected to the data center core routers. Let's go ahead and commit these configurations. Now that that's configured, I will go ahead and finish the configuration by wrapping it up by adding a host-facing configuration plan. So now that we're configuring the host-facing interfaces, this is where we're configuring VLANs and VLAN interfaces. These hosts in this environment are going to be using VLANs 11 in rack for the switch connected on the left in that image that I showed you, and VLAN 12 on the switch connected onto the right. I've created the VLANs. Let's create the interfaces now. Okay. Now, of course, this is VSX, so I'll configure the variable IP addresses. Core 1 will have .2, core 2 will have .3, and then the active gateway IP address will use .1. Same thing with VLAN 2. I'll follow that same pattern, .2 for core 1, .3 for core 2, and the active gateway IP address will use .1. Okay, so now we've got the VLANs and the VLAN interfaces configured. Now we need to configure the multi-chassis link aggregations, because these are going to be facing the servers that are going to be configured, right? So let's do interface lag 11, and this is going to be multi-chassis. We'll do the no shutdown command. Now this one is going to be to a Windows server, bare metal. And we're just going to do a standard VLAN access interface with active LACP mode in an active state. Whoops. Let me type that properly here. And then I'll create the other lag interface, which is going to be lag 12. Again, multi-chassis. No routing, no shutdown. This one will be, whoops. That again. This one's actually to an ESXi host. And very much like we did on the other one, I'm just going to do an access VLAN, which is VLAN 11. We're going to do LACP mode, which is active. Now, whether the interface is tagged or not will vary, of course, within the environments. In this example, I'm simply using access VLANs. Now that I've got the multi-chassis link aggregation configured, now let's finally configure the actual interfaces that these will be used on. So I'm going to do interface 111. And this will be a no shutdown. The description, this one's to the Windows host. And this will be lag 11. And we'll do interface 112. This one is to the ESXi host. And this will be lag 12. Okay, let's take a look and validate this configuration and make sure I didn't screw anything up. Okay, everything looks good. So let's go ahead and return to this plan, and I'm going to go ahead and click deploy here. Okay, so the plan has been deployed. So let's go ahead and take a look at the change validation. So when we're looking at the change validation, let's look at the show interface brief. So we can see here that ports 111 and 112 weren't up. They were down before, and now, of course, they're up now. Let's take a look at show LACP interfaces. So these are my link aggregation interfaces facing the two hosts that are connected to ports 111 and 112. I want to see that these are all in an active and a distributed state, but I see one that's not. So let me go ahead and click refresh, because we want to get a quicker or a more up-to-date view of the status of the network now that the config has been deployed. And now once I click refresh, we can see that when I'm looking at core 2, the link aggregation groups are all up and running in an active state and distributing. We will have the same configuration on core 1. And of course, the same thing with the pings. Before we started, I added a ping in here to make sure that we could ping the hosts once the hosts were up. And of course, 12.1.1.12 is one of the hosts. And then of course, we have the other host, which is 11.1.1.13. So we've successfully deployed a collapsed core solution using NetEdit. Now that I've validated that the configuration is accurate, I'm going to go ahead and click commit, and we're good to go.